Write a possible equation in standard form for p of x. And zeros of p of x are -1, 2, and 3 minus square root of 5. We notice that two of the zeros of p of x are -1 and 2. They are both integers or rational numbers. And this 0 here is an irrational number because of the square root of 5. But we know that irrational zeros come in pairs. Therefore, there's a 0 that is not listed here, and that is the conjugate of 3 minus square root of 5, which is 3 plus square root of 5. So therefore, p of x has actually 1, 2, 3, 4 zeros. So now that we have all the zeros, we can now write p of x in factored form. So let's start with p of x is equal to, I'm going to put just x minus for now. I'll put the zeros later. So x minus, x minus, x minus. All right, so now I'm going to put the zeros. So the first one is x minus -1. Next one is 2, x minus 2, and then x minus, because that's a binomial, I'm going to enclose it in a grouping symbol. So I'll have here 3 minus square root of 5, and here we'll have 3 plus square root of 5. Okay, then we'll simplify. We'll have p of x is equal to x plus 1 times x minus 2 times, but this one we distribute the negative, so we'll have x minus 3, negative times negative is positive, square root of 5, times x, again distribute the negative, so this will be minus 3, and this will be negative square root of 5. So now to put this in standard form, we just need to multiply these 4 factors. So I'm going to multiply these 2 together first, and then these 2 together, and then we'll multiply the results after. So let's find the product here. On the top, we'll put x plus 1. On the side, x minus 2. And for this, we'll put x minus 3 plus square root of 5. And then here, x minus 3 minus square root of 5. So let's go back to this. X times x is x squared. X times 1 is x. Negative 2 times x is negative 2x. Negative 2 times 1 is negative 2. Therefore, the product here is x squared minus x minus 2. Well, here we'll have x squared, negative 3x, x times square root of 5, negative 3 times x. Negative 3 times negative 3 is 9. Negative 3 times square root of 5. Here it's going to be negative x square root of 5. And here 3 square root of 5. And last, negative square root of 25. So now we know that this will be x squared. Negative 3x minus 3x is negative 6x. Negative x squared of 5 and positive x squared of 5 could be cancelled. So we'll have here plus 9. And then 3 square root of 5 and negative 3 square root of 5 will be cancelled as well. And then minus square root of 25 is minus 5. Therefore, this is x squared minus 6x plus 4. So now we will multiply these two. So we'll need another 3 by 3 in here. Okay, so here we can put x squared minus 6x plus 4. And here we'll have x squared minus x minus 2. So now let's multiply. We'll have x squared times x squared is x to the 4th. This is negative 6x cubed. And this is positive 4x squared. Here negative x cubed. Here positive 6x squared. Negative 4x. Negative 2x squared. Positive 12x. And here negative 8. So the answer is p of x is equal to x to the 4th negative 7x cubed plus 8x squared plus 8x minus 8. All right, so let's graph p of x and see if it satisfies all the conditions. So I'll put here p of x is equal to x to the 4th minus 7x cubed plus 8x squared plus 8x minus 8. Okay, let's take a look at the graph. So the graph has 4 zeros, 4 x-intercepts. So these are the two, oh no, not this one. The two integers, zeros, and the other two are the irrational zeros. Okay, so let's check if these numbers are corresponding to those irrational zeros. So let's put here 3 minus square root of 5. And the value of that is 0.76393. Now here, 3 plus square root of 5. And that's what we get here. So let's check the picture again. Do they match? Yes, they do. So we found the equation for p of x in standard form.